Okay guys, so I'm back. This is part 2 of test 5. We're going to start with number 14. So this is a long problem too. This is going to be division of a polynomial. Remember, a polynomial is simply an algebraic expression that has many terms in it, particularly when you see different exponents. And here we have 3 different terms. We have x to the third power, we have an x to the second power, and then we have a constant term here. So this is considered a polynomial. And we want to divide it by x minus 3. So we're going to work through this problem. I've already got it written down here for you. I want you to notice something. I'm adding in another term, and I want to show you why. Notice what this actually says is x to the third minus 2x squared minus 1. What is not in there is just a regular old x term. But we need to have that when we make this long division. You got to have all the terms in there in descending order. So you need to have an x term in there, or an x to the first power term, where we have a 3, an exponent of 3, an exponent of 2, and an exponent of 1. Okay, so you got to put that in there. But since there's no value for it, we're going to put 0x in there, because that actually, 0 times x is 0, right? So I'm not really changing the value of what I have here, but I need to have the x term in there, because when you do the division of this problem, excuse me, this divisor of x minus 3, I need to have all my x terms in there with all the exponents in descending order. Okay, so I just got to plunk it in there, poke it in there, but put a 0 with it so it actually multiplies out to not have a value, or a value of 0. All right, so let's start this thing. So I will actually start, my first term is actually going to be written right here. Okay, I don't remember where this falls in the Algebra 1 book from last year, but hopefully you saw this and this isn't the first time that you're going to see this. Hopefully it'll jog your memory. If not, you will continue to have practice of this type problem since Saxon repeats its practice problems, so this will not be the only time you'll have a chance to do one of these problems. Alrighty, so I look at this thing, kind of follow me here. I look at this thing and I think, what x squared term can I write above this that when I multiply it, it's going to give me an x to the third? I want you to watch what happens here. So if I put an x squared term up here, I'm asking myself, what multiplied with this x will give me x to the third? So x squared that I just wrote up here times this x, where my arrow is pointing to, will give me x to the third. Okay, this is just like a long division problem that you would have when you don't have a polynomial in there. Okay, process works somewhat similar. So x squared times x gives me x to the third. Now I want to take this x squared and multiply it with negative 3. And I'm going to get negative 3x squared. Do you see how that lines up below there? Now I want to subtract this. So in my head, now I'm actually going to write it out. Saxon says just mentally make the change. But I'm going to actually make the change, because I'm going to subtract it. And when I subtract it, if I'm going to change the sign of that x to the third by subtracting it, then I need to change this one too. Okay, so essentially what you're doing is you're changing the signs of both of those in there. So I'm subtracting x to the third, and that's going to actually give me 0 down here, right? And I'm not going to write it, that part I can do mentally. But I do need to write down here, negative 2x squared plus 3x squared will leave me with an x squared. Okay, now I go back up to the top and I ask myself, what times x will give me x squared? Well, simply x, right? X times x gives me x squared. And then I have to take that same x and multiply it with the negative 3. So it would be x squared minus 3x. Notice how I'm lining it up. Okay, now I'm going to get rid of those arrows because they get a little bit in the way. Okay, again, I need to subtract this because I want these x squareds to cancel out. And when I do that, I got to change the sign on both of those. Okay, so x squared minus x squared cancels out. I can actually kind of put the line through it so you can see that. And I add together 0x plus 3x, and I end up with 3x down here. I'm going to do the same thing up top here now. What can I multiply? What am I going to put right up here that when I multiply it with x will give me 3x? Well, that would be a positive 3, right? So 3 times x gives me 3x. And 3, let me change the color here, and 3 times a negative 3 will give me negative 9. Okay, so let's get rid of those arrows because it gets really messy. Go back and get my blue. So I have 3x minus 9. Oh, wait a minute. Whoops. I made a little, what did I do here? 3x. I have a 3x. Oh. Okay. Hang on a second, guys. I had 3x here. So that needed to go here. 3x minus 9. I added them together. I'm sorry. So I got 0x plus 3x gives me this 3x here. And then when I did my when I did my multiplication of 3 times x, I got 3x, and 3 times a negative 3, and I got the negative 9. Okay? Now you can see that. So now I want to subtract that, which is going to change the signs on both of those numbers. These cancel out, and I'm left with negative 1 plus 9. I'm left with 8. There's nowhere else I can go. I have a remainder of 8 down here. And remember how we write those? When we write that as a fraction, I'm going to have a remainder. Whoops, gracious day. I'm going to write that as a remainder of, we're going to put plus 8 over x minus 3. Remember how we would do that before? If you have you can write your remainders as a fraction by taking the 8 down here, and then you take your divisor out here, and that becomes the bottom of your fraction for your remainder. So believe it or not, the answer is this. Now, they want you to check this. The test says to check this. I think I'm going to skip that. Maybe we'll kind of go over that in class on the next problem that you come across. If you have to check it again, we'll do that. But let's just leave that right there as your answer. You see how we've arrived at that? Please make sure you've written that all down so you have an example. Let's look at number 15 now. 15 on the test says we want to solve this long equation here for x. So let's go ahead. I'm going to write it in. Negative 2 times negative 3 times negative 2 minus x. I see a lot of negative signs in here, so I can tell already we need to be very cautious when we're working through this. Equals negative 2x. All right, 15. Here we go. Let's do as much as we can. I'm going to leave the negative 2 outside here because remember PEMDAS says you go to the innermost parentheses first. Let's solve what we can to get it simplified, and then we can do whatever combining after that. So I'm going to do some distributing here. So I say I have 6 plus 3x plus 2x minus 6 equals negative 2x. I'm going to go ahead and leave the negative 2 out here. And I'm going to combine what I can. I see here I have 5x. Oh, and 6 minus 6 is 0. It's going to work out pretty nicely, pretty quickly. So then I have negative 10x equals negative 2x. I'm going to add 2x to both sides, or you can do 10x to both sides. It doesn't matter. I'm going to end up with 0 and negative 8x. I'm going to divide both sides by 8 because we're trying to isolate x. 0 in the denominator is okay. That ends up being x equal to 0. Remember, if you have a 0 in the denominator, if it had turned out that way, that's undefined. You cannot have a denominator of 0. Okay, so x is equal to 0 and number 15. That was quick, easy, and painless. Let's go look at number 17. 17, we're simplifying. Maybe I'll write this one right over here. Okay, on 17, I'm going to try to combine those things that I can right off the bat. So I notice here, first of all, I notice that this is going to end up being 1, so I'm just going to cross it out. So I'm going to have negative 3. Look what's going to happen here. Negative 3 is going to be squared here. Do you see that? But I'm going to go ahead and write it out so I can go ahead and combine some of these terms. I have an a to the third times a to the first, so I'm going to have a to the fourth. And then I have a few c's. This one's going to be 1, so I can just cross that one out, and I'm going to end up with c to the third right there. All that over, I have negative 3 to the negative third power. I'm going to handle that by actually moving it to the top. But before I do that, I'm going to leave it right where it is for just a moment because I want to handle the rest of this part first. So let's do, I have a to the third, it looks like. And c, this is going to be a 1, so I can just cross that out. And I have c times c to the negative second power, so that's going to be c to the negative first power. Okay, and now I'm going to move some of the stuff around. So let's look at this negative 3 to the negative third power. If I move that to the top, I'm going to have negative 3 to the third power. Ends up becoming, oh, wait a minute. You know what? We're not going to do that just yet. Let's take care of what is actually up top here. So I have negative 3 squared. That's a 9, a to the fourth, c to the third. And now I'm going to bring it up here. I'm going to bring up negative 3 to the third power. Okay, so I moved this to the top. And I'm also going to bring this to the top, c to the first power, all over a to the third power. All right, so now let's see what I have. This equals 9. Okay, so I have a to the fourth on the top and a to the third on the bottom, right here. So we can subtract those exponents. That would be a to the first or just a, right? And then I have c to the third and c to the first. So I can combine those by adding those exponents since they're being multiplied. So that would be c to the fourth power. And then negative 3 raised to the third power. Be careful on this, okay? That exponent of 3 is only affecting the 3, not the negative. It's not on the outside of the parentheses, so it's only attached to that 3. So that's going to be a negative 27. Oh, and then we got rid of that denominator, so there's nothing left there. Remember, we got rid of that. Okay, so now we just do the math here. You do 9 times, I'll write it right below here, the negative 27. You should end up with negative 243, a times c to the fourth. And that would be your final answer to number 17. Okay. Number 18, I'm going to go ahead and rewrite it because I need a little bit more room than what's given there. So we'll start right here. Number 18 starts out as 4m cubed over n squared. These m's and n's crack me up. Let me get the test. 18 plus 2mn to the negative second m to the second power minus 6m over n squared. Okay, so a lot of these problems are just keeping track of your negative exponents and adding and subtracting them when appropriate. So it looks like the first one, there's not much we can do, so we're just going to rewrite it as it is. I can't cancel that. Anything doesn't cancel, so we leave it as is. The second part of this, though, I notice that I have a negative exponent on my n, and it looks like I can combine my m's. So let's do that. So I have 2m to the third, and I'm going to move the n to the second to the bottom. And then on the third one, I can combine my two m's like so. And actually that 6 can go on the top there, right? Because that would be like multiplying like so. So we have 6m squared over n squared. Now, notice my denominators. Isn't that a beautiful thing? I have all the same denominators, so I can actually put my numerators together and the same denominator underneath. So let's see what we have here. I'm going to go ahead and put it all up here. 4m to the third power plus 2m to the third power. Ooh, this is really nice. To the second power. Because I can combine those terms right there. So I'm going to end up with 6m to the third power minus 6m to the second power all over n squared. And that's your final answer. All right, that's number 18, and yay, yahoo, we're on to the last one. All right, I would like to see if maybe I can do it right here. Try to write kind of small. All right, so let's look at that way I don't have to rewrite it all out. Okay, so let's just take a gander at this. Let's see the things that I can actually do together. So I'm looking here at these two. I can make a -2, right? Inside my absolute value, I'm going to end up with a 3. Anything else? This is going to turn into a 1. Keep the negative sign there. So let's rewrite what we have. -2 to the second power is going to be a -4. Remember that power of 2 is only affecting the 2. It's not affecting the negative sign, so you have to keep the negative sign there. Inside the parentheses, we're going to have a -2 minus 3. Absolute value of 3 is 3. Oh, minus, now I'm way over here. Looking at that right there. Minus 3 times, and I'm going to just go ahead and put what's inside here. I have a -1 minus a 3. Okay, now I can handle what's on the inside here. I have -4 minus 2 minus 3. I'm going to drop the parentheses off so we can see what we have. -3 times a -4. This is getting pretty long, isn't it? But we're shortening it. That's the good news. Then I'm going to have -4. I'm going to keep simplifying what's on the inside here. I have -5. And -3 times the -4 is plus 12. This is going to equal -4 times 7. And you'll get -28. Should be your answer for number 20. We have finished the test. Boy, Algebra 2 gets long, doesn't it? Okay, guys, so that's the end. I'm going to go ahead and get this one posted for you. Feel free to use the ones that you need. These are going to be due on Tuesday when you come to class. And then I think we're going to go ahead and start in the book with the next lesson. So enjoy your weekend once you get this done. And I'll see you next week on campus. Have a great weekend.